Welcome back, listeners, to another exciting episode of Operating Systems Crashcast. I'm Victor, and with me, as always, is the brilliant Sheila. Today, we're diving into a crucial aspect of operating systems: system calls. Sheila, are you ready to explore this fundamental concept?
Absolutely, Victor. I'm thrilled to discuss system calls with our listeners. They're like the secret handshake between user applications and the operating system kernel. Let's start by explaining what system calls are and why they're so important.
Great idea, Sheila. System calls are the interface through which user-level programs request services from the operating system's kernel. They're essentially the gateway for applications to access hardware resources and perform privileged operations. Think of them as a bridge between the user space and the kernel space.
Exactly, Victor. And it's crucial to understand that system calls are necessary because of the way modern operating systems are designed. They use a protection mechanism called dual-mode operation or privilege levels to maintain system security and stability.
That's right. In simple terms, there are two main modes: user mode and kernel mode. User applications run in user mode with limited privileges, while the operating system kernel runs in kernel mode with full access to hardware resources. System calls allow user programs to request the kernel to perform operations they can't do directly.
Great explanation, Victor. Now let's talk about how system calls actually work. When a program needs to perform an operation that requires kernel-level access, it makes a system call. This triggers a switch from user mode to kernel mode, allowing the operating system to execute the requested operation safely.
Absolutely. It's like going through airport security, Sheila. You can't just walk onto the plane. You need to go through a controlled checkpoint. Similarly, system calls provide a controlled way for user programs to access kernel services.
That's a great analogy, Victor. Now, it's important to note that programmers usually don't invoke system calls directly. Instead, they use an application programming interface, or API, provided by the operating system. The most common example is the POSIX API, which stands for Portable Operating System Interface, used in Unix-like systems, or the Windows API for Windows systems.
Good point, Sheila. The API acts as a higher-level interface that's easier for programmers to use. It abstracts away the complexities of direct system call invocation. To continue our airport analogy, the API is like the check-in counter where you interact with staff, while the actual system call interface is more like the security checkpoint behind the scenes.
Exactly. And just like how different airports might have slightly different check-in procedures, different operating systems may implement system calls differently. However, the fundamental concept remains the same across most modern operating systems.
That's a crucial point, Sheila. Now, let's briefly touch on the types of system calls. While we'll cover this in more detail in our next episode, it's worth mentioning that system calls generally fall into several categories, such as process control, file manipulation, device management, information maintenance, and communication.
Absolutely, Victor. For example, when you create a new process, open a file, or send data over a network, you're indirectly using system calls. They're the unsung heroes working behind the scenes of almost every operation we perform on our computers.
Well said, Sheila. Now let's discuss an important aspect of system calls: parameter passing. When a program makes a system call, it often needs to provide additional information to the kernel. There are three general methods for passing parameters to the system call interface. Can you explain these methods, Sheila?
Certainly, Victor. The first method is passing parameters in registers. This is the fastest method, but it's limited by the number of registers available. The second method is storing parameters in a block or table in memory and passing the address of the block as a parameter in a register. This allows for more parameters but is slower. The third method is pushing parameters onto the stack by the program to be popped off the stack by the operating system.
Excellent explanation, Sheila. It's worth noting that different operating systems might use different methods or a combination of these methods. The choice often depends on the system architecture and the specific needs of the operating system.
Absolutely, Victor. And for our listeners who might be preparing for interviews, understanding these parameter passing methods can be crucial. It demonstrates a deeper knowledge of how system calls actually work at a low level.
Great point, Sheila. As we wrap up, let's recap the key points we've covered about system calls. They are the interface between user programs and the kernel, allowing controlled access to system resources. They work by switching from user mode to kernel mode, are usually accessed through APIs, and can pass parameters in various ways. System calls are fundamental to the operation of modern operating systems, enabling everything from file operations to network communications.
Excellent summary, Victor. Understanding system calls is crucial for anyone working with operating systems or developing software that interacts closely with the system. They're the backbone of how our applications interact with the computer's resources.
Absolutely, Sheila. And that brings us to the end of today's episode. Thanks for tuning in, listeners. Join us next time as we dive deeper into the types of system calls. Until then, keep exploring the fascinating world of operating systems.